This lesson is on converting between rational exponents and radical notation. So we already practiced this way a little bit in our last lesson, but obviously we're taking it to the next step. So a to the 3/5, I know that I can write that in a couple of different ways. I can either write a to the 3rd and then the 5th root, or I can write the 5th root of a and then to the 3rd power. In this case, it really doesn't matter. Either way is correct. Either way, I can't simplify it any further. For my second one, however, let's be careful because this is 5 to the 1/3, but x is to the 2/3. Now, notice they both have 3 as an index, so it is going to be the 3rd root, but 5 is to the 1st and x is to the 2nd, so it's the cubed root of 5x squared. That's the final answer, the way that I would write it. Be careful on these two questions because notice on these two, the 3 is not to the 1/4 power and the 9 is not to the -3/4 power. So here, it's 3y to the 1/4. The y is to the 1/4 power, so I have a 3 on the outside, and then I have the 4th root of y. So 3 on the outside, and then 4th root of y. This one I have 9, but the z is the only thing to the -3/4 power, so I have a 9 here. The negative says that this z to the 3/4 actually goes on the bottom of a fraction. And then of course it's cubed and the 4th root. So there's the 3 and the 4. Here's some of those for you to try. So do all 4, then press play to see how you did. The first one, I have t to the 4/5. So again, I have t to the 4th, and then I have the 5th root of that. For my next 2 to the 1/4, y to the 3/4, again, both are to the 4th root, but this is 2 to the 1st and y to the 3rd. 10, p to the 1/2, again, 10 is not to the 1/2, but p is, so square root of p. Remember, you don't need to write it if it's a 2. And last one, 11q to the -2/3. 11 is not affected by the -2/3. Q goes to the bottom because of the negative, and then it's squared and the cubed root. Now this is going in the opposite direction, which we have not practiced yet. So now we have we have radicals that we have to turn into a rational exponent. So we know that whatever the exponent is the numerator, and whatever the index is the denominator. So I would rewrite this as b to the 4/3. b to the 4th, cubed root, b to the 4/3. 5x all to the 1/2. I can either write this as 5 to the 1/2 and x to the 1/2. Typically, however, I would just write 5x in parentheses and then to the 1/2 so that I know that the square root applies to everything. This one is different. I have 5 on the outside, but x to the 1/2, so it's 5 x to the 1/2. Again, here x is the only thing to the 1/2. And then because 11a is a denominator, I would say 11a to the -1/2. So the negative saying that's on the bottom, the 2 the index, the 1 because there was no exponent on either one of those things. Here are 4 for you to try. So try all 4, then press play to see how you did. For the first, I have x, I have the 4th root and to the 3rd power, so that's x to the 3/4. Be very careful when you're writing these, because if I write x to the 3/4 like this, it looks like x times 3/4. It gets a little bit crazy, so make sure it is an exponent. For my second, I have a fraction, which means this is a denominator that was taken to a negative power, so 3xy all to the -1/2 power. Negative, which is what put it on the bottom, 1/2 being the square root. 6 and then y, the cubed root of y, so 6 is not affected at all by anything. There's no exponent, there's no index. Y, however, is to the 1/3 power, so the cubed root of y. And this one is different because 6y is all to the 3rd power, so it's 6y in parentheses and then the 1/3.